Well, hi guys, and it's time to do another video class. Today we will be discussing the notes for section 7.3. Couple of quick reminders before we get started. One, at this point, you should have already turned in your homework for homework 16, which went along with section 7.1. You should be working, and you will have until tomorrow to turn in the homework for our live class session from last Friday, section 7.2. And today we'll be moving on to section 7.3 to get ready and prepare for our upcoming quiz. I believe we have only one section left in section 4 in chapter 7, and then we will be moving on into our test for this section, and then we'll be going on ahead and continuing with chapter 8, which is the next portion of our text that we want to complete for this course. And yes, indeed, we have one more lecture. So we will have a lecture on video today on section 7.3. And you'll have another video lecture on Wednesday for section 7.4. And then on Friday's live meeting, we will talk about any questions you may have and some of the things you can expect to see on your test, which will then go live after our meeting on Friday, and you will have until a couple of hours thereafter to complete it. I think I'm going to leave it open for about 3 hours. If you're going to have any kind of time conflict, you have to let me know during our live session so we can talk about when we can have that test be available to you. But that is the plan as it stands right now. And I think that's all we need to do housekeeping wise. We're doing great so far, and our pacing seems to be on point. So I think we're in a good place as things stand right now. Let's go ahead and get started with section 7.3 notes today. So I'm going to go ahead and share my screen with you now so that you can see the notes. Okay, let's get that on big screen for you. There we go. So as you can see here, we are starting section 7.3 in chapter 7 with a discussion on ratios. Now, ratios, as you can see, are defined officially as an ordered pair of numbers written as A colon B or A over B. When we write it as A over B, this would be the notation we use when B is not equal to 0. This, however, does not mean that in ratios, the B part can never be 0, as you will see shortly. But let's discuss a little further what it is, why it is that we want to talk about ratios. The reason why ratios are a useful mathematical tool is that it allows us to compare the relative sizes of two quantities as quotients. In other words, we are comparing them by division, which is a very useful way of comparing numbers, especially when you're talking elementary school. At this point, you would have taught children, excuse me, something in my eye. You would have taught children to compare numbers using subtraction. You would tell them that subtraction allows you to find the difference between two numbers, and it also allows you to determine which number is larger and which number is smaller. Ratios allow you to compare how one quantity is compared to another quantity by relative size, meaning how many times bigger or how many times smaller, which is one of the reasons why ratios can be so useful. Now, important note, and this is why we highlighted earlier that although we do write ratios as what looks like a fraction when b is not equal to 0, because as you know, in fractions, the denominator being equal to 0 means the fraction's undefined. But when we're talking about ratios, unlike fractions, as you can see in the highlighted portion here, there are instances where we allow b to be equal to 0 because it depends on the kind of ratio we're discussing. For example, if we were talking about the ratio of men to women on a baseball team, a professional baseball team, then that ratio would be 9 to 0. Since at this time, we do not have a professional women's baseball team. We have professional women's softball teams, but not baseball teams in the MLB, something that probably should be rectified. But that's a conversation for another day. Now, before we go a little bit deeper into ratios, let's talk about notation, meaning how we write ratios, how we read them, ways to express and write them. So first of all ratios are always read from left to right, and we say them as A to B. That's the phrase we use to read them. Now, here are the different notations we can use. We can use the one you saw in my original definition of the colon, where we say A to B, and we read the word to for the colon. Or we can write them in what's called fractional notation, hence why it's in this chapter where we've been discussing decimals immediately after having discussed fractions in chapter 6. And again, we read this from top to bottom, and we would once again say A to B. Finally, we have this way of noting ratios, and this is where we read them again from left to right, and it's A per B, because the term per, as you can see here, means for every. So what we're saying here is that we have A quantity for every B quantity. Now, when discussing ratios, we have two basic types of ratios that are useful to us. The first type is called part to part, and this is where in the ratio what's being compared, A and B, are parts to parts. For example, if we're talking about children in a classroom and we are choosing to compare the number of boys to the number of girls, that is a part to part comparison. We're talking about the part boys out of the total number of children in the classroom and the part girls out of the total number of children in the classroom. So we are comparing part to part, and we could write that as boys to girls using the colon notation, or boys to girls using the fraction notation. We could use the per notation, but it's not really appropriate for this type of ratio, since we're not really saying there are this many boys for per every girl. But you can use it. It's not incorrect. Then the other type of ratio that we have is when we use part to whole, or if you want to flip that on its head, whole to part. Either way, same type of comparison. And this is where, for example, if we're talking about the children in a school and we compare the number of boys in the school to the number of the student body in the school. So this would be boys to students. And if we're using that kind of a ratio, then it is a part to whole situation. And again, this would be part to whole, both using the colon notation, as you see here, or the fraction notation. And again, we can still use the per as well. But again, it feels a little awkward for this particular type of problem, which is why I didn't use it. All right, so now that you have a little better understanding of ratios, let's talk about equality of ratios. And here again, the fact that, as you heard me say earlier, ratios are related to fractions, and we just finished discussing 2 sections in this chapter about how decimals are related to fractions. You will see that we can find what's called equality of ratios, and really in your head, to make this very easy to understand, think equivalent fractions, because it's a very similar relationship. Officially, the definition of the equality of ratios is as follows. It is defined as, if we let A to B and C to D be any 2 ratios, then A to B is equal to C to D. Please note that we call the A and D, moving from left to bottom right, the extremes when it comes to these 2 ratios that we're talking about. And B to C, moving from left to top right, as the means. This will be important in a little bit, so bear that in mind. Once again, this definition is saying if we let A to B and C to D be any 2 ratios, then A to B is equal to C to D if and only if the product of A and D, or the extremes, is equal to the product of B and C, the means. And we usually find this by finding what other places you may have heard it called the cross product. So basically, what is the equality of ratios definition saying? It's saying that if you have 2 ratios that you can set equal to each other, you can say that they are indeed equal to each other if and only if the product of the cross product of those two ratios, or the product of the extremes, is equal to the product of the means, okay? Let's look at an example to make it even clearer. So let's say that we're comparing the ratio of boys to girls in classroom 1 and in classroom 2. In classroom 1, we have a ratio of 8 boys to 6 girls. In classroom 2, we have a ratio of 4 boys to 3 girls. Therefore, if we write these ratios as 8 boys to 6 girls, representing the ratio of classroom 1 of boys to girls, and 4 boys to 3 girls, representing the ratio of boys to girls in classroom 2, and we take their cross product, multiplying the means, 8 boys and 3 girls together, and then multiplying the extremes in blue. Pardon my mistake there. Let's try that again. Multiplying the extremes, 8 times 3, and then taking the product of the means, 6 times 4. If 8 times 3 is 24, and 6 times 4 is also 24, since the product of the extremes is equal to the product of the means, we can state that these two ratios are indeed equal to one another, or equivalent. Now, if we weren't talking ratios, you could have come to that conclusion yourself, because you would have noticed that 8 over 6 and 4 over 3 have common factors, right? If you take a 4 out of the 8, you're left with 2. If you take a 4 out of this one, you're left with 1. If you take a 2 out of the 6, if you take a 3 out of the 6, you're left with 3, and so forth. If you take the 3 out of here, it's 1 over 1, and again, you've got 2/3. So you could see that they are multiples of each other. 8 is a multiple, 4, and 6 is a multiple of 3. And as you know from fractions, that means that this is an equivalent fraction to this, right? Because they're multiples of each other. Now, a proportion, not to be confused with a ratio, a proportion is when we do take two ratios and say they're equal to each other. And we use that fact that we know they're equal to each other and the way that we can check for the equivalence of them as an assistance in helping us to problem solve, which is what you see here. It says that a proportion is an application of ratios and it is useful in problem solving. Now, official definition of a proportion is a statement that two given ratios are equal to each other. Let's look at an example. If we say that a school orders 3 cartons of milk for every 7 students, and if there are 581 students in that school, how many cartons of milk does that school order? Well, we take the ratio of 3 cartons of milk for every 7 students, and we set that up as our first ratio. And we say that that has to be equal, because it must be an equivalent ratio, right, to the number of cartons ordered for the entire student body of 581 students. Then we use the fact that since we're saying they're equal, we can check that equality by using the cross product. So we can go and take the product of our extremes, 3 cartons times 581 students on one side, and our means, 7 students times X number of cartons. And now we've set up a nice little equation. 3 times 581 is 1743. And obviously X times 7 is 7X. Now we have this nice little equation where we have 7X equal to a quantity, and we can go ahead and solve for X by dividing by 7 on both sides. When we do that, we have that X is equal to 249, meaning that the school would have to order 249 milk cartons for its 581 students if they want to give if they want to use 3 cartons for every 7 students. Now, over here on the side, I want you to notice something. Earlier, we mentioned how there are 2 types of ratios that we can use. We can use them together in the same problem to solve problems. For example, you'll notice that 3 cartons to 7 students is a part-to-part ratio, whereas the one that we're solving for, X number of cartons to 581 students, is a part-to-whole ratio. So that's usually the kind of setup that we end up having when we're using ratios to help us solve problems. Now, there you have it, ladies and gentlemen. We have completed section 7.3. It was a very short section. I hope that you enjoyed this video and that you are doing well and that you're able to keep up well with your classwork. Please complete the homework that accompanies section 7.3. It's already posted for you on the task portion of our Blackboard homepage, as well as in this assignment where you will find the link to the notes if you wish to print them out for yourself, and this video for you to watch. All right, see you later, and I will see you next time on our video class for Wednesday.